clear? Just a minute.
Introducing new slide class.
Just a minute. Over. Okay. Check the no. Still little less are required. Voice clear? No recording. It's already recorded. Can I start? If the voice is clear, I will start. See, little lag will be there. You have to give answer little fast. Okay, I'll start. So as I told, this class is, see, today is Wednesday. Today, tomorrow and day after tomorrow, 3 classes I will take in YouTube. That is how to find axial load carrying capacity or axial load resisting capacity for a column, for single sections, built up sections, all that will be covered. Very important. You can refer any time. See in your course, what all classes taken in the Zoom, it will be deleted after some time, but this will not be deleted. So basic concept. Now remember, this actually is after I started columns. This is class number 4, I think, correct? In the previous 3 classes, I told all the basic concept, like what is FCD, how to calculate, how FCD considered, Euler's formula, Rankine's formula, short column, long column, how buckling comes. Buckling can come about any axis. All those things are told in the earlier classes. But now, this is one, see, Those who are in the regular in the group, you get it in the earlier classes. For general public, this is meant for finding capacity, axial load, resisting capacity for a column. That's all. Theory already covered. So, I written brief statement here. How to calculate. And one more thing, remember, important. When you consider effective length, one effective length will be this way. This effective length. That will be about this axis. One more effective length will come here. That will be about this axis. But usually for columns, effective lengths are same for both with respect to both axes. If not same, remember what you have to do? You have to calculate KL divided by R about ZZ. KL about ZZ by R about ZZ. 1 lambda will come. For that you have to find FCD. Then again KL by R. Now with respect to YY also you have to calculate and find FCD and take the least FCD as the strength. Okay, that is finer point. But in all these classes this week, remember for all examples, example this week, that is your part 1, part 2, part 3 as put, you consider KL effective length is same or constant with respect to both axes, both principal axes of the cross section. If somebody will ask, if not same, what to do? It comes in the main course, already told for you, yes or no? It came in the main course, already told. That all if I discuss here, this will be go beyond the limit. So, and those who are studying for examination point of view or any competitive examination, usually it will be same. Practically also, unless there is a intermediate bracing etc. comes, effective length is same. So today's class, today Wednesday, tomorrow and day after tomorrow, all these 3 days, remember only one effective length will be given. That effective length is for x axis or z axis. Sorry, x axis is not there. That effective length is with respect to both the axes. Clear? So in all the examples now, effective length given is same with respect to both principal axes. Clear? First, it will be same with respect to both principal axes. Okay, start. Now, this all we discussed. Remember, 3 days we discussed, yes or no? All these principles we discussed for 3 days. Every concept is considered. Now, brief procedure. Design compressive strength as per IS code. See the page number. Means what? Maximum factored axial compressive force that can be resisted. Factored value, not working load. What is the maximum axial factored compressive load? In RCC you call ultimate load. Column can resist. PD equal to FCD into AE. AE is effective cross-sectional area. See, one more thing. For all these 3 classes, your effective cross-section area equal to actual cross-section, actual gross area. Gross area or simply A. That's all. But sometimes a little area to be removed. That I will discuss in the group later. Because why? It will not come here. Sometime if section comes semi-compact, for plastic, compact and semi-compact, no problem. But if the section becomes slender, IS code told a part of the area is to be removed. Okay. That is, you have to ignore that area. That all will come subsequent classes. So in all the classes for compression members, your AE effective area is nothing but cross-sectional area A. Remember, I write AE equal to cross-sectional area A. Cross-sectional area A. FCD is design compressive stress. Design compressive stress means how much compressive stress is allowed. It depends upon slenderness ratio. More and more longer column and thinner column is weaker, you should apply lesser load. Or shorter column and bulging column, strength is more, you can apply higher. That all will come, that all we discussed regarding slenderness ratio also. So FCD is design compressive stress or maximum allowed compressive stress for factored load. Now, what is the procedure? Consider the case when effective length KL is same with respect to both principal axis of cross section. That is, KL, effective length is KL with respect to ZZ equal to KL with respect to YY, or simply we will put KL. Okay, then see, I told you, if effective length is same, one of them is KL by RZZ. Yeah, have it XX. Other is KL by RYY. Tell me, which is stronger, which is weaker? It will be stronger when what? KL by R is more or lesser. Column becomes stronger when KL by R becomes what? More or lesser. Column becomes stronger when KL by R becomes strong, more or lesser. Column becomes stronger when KL by R becomes. No answer. See, so much discussion is made. What is the answer? KL by R is lesser, correct. KL by R is lesser. When KL by R is lesser, it tends to become short column. Okay. But when you find the strength, one of them is stronger, one of them is weaker. Tell me, strength always depends on stronger or weaker. Write it if you want. Strength always depends upon stronger or weaker. This I am shouting class after class throughout my teaching. When you find strength, always the weaker is the critical. Therefore, you find what? KL by RZZ, KL by RYY, and then consider whichever is what? Whichever is higher value, or to critical is when R is, tell me, when denominator is higher or lesser. This you know in strength of materials. Critical is when R is more or lesser. Critical is when R is more or lesser. Critical will be always when R becomes what? R becomes. You are not told. Critical is when R becomes what? Again, you are not answering. You are telling ISHB 358 lesser. So remember, when you make a note, when important note, when what? Effective length is constant with respect to both principal axes, then for strength calculation, always consider least R or R minimum. Okay, that you remember. Now, so what you do? Consider effective length same with respect to both. Then consider least radius of gyration of cross section R minimum. Find slenderness ratio of the column KL by R minimum. Then decide the buckling class, that is A, B, C or D, referring to table 10, and accordingly refer what? Accordingly refer table 9A or 9B or 9C or 9D and get FCD, substituting get PD. Over. This is a procedure. So procedure is what? But remember, always when you solve a question, make a practice. First you write cross-sectional properties. First write cross-sectional properties. Remember, make a note. Whenever you start the question, always first write cross-sectional properties. Our most important is area, R about ZZ, R about YY, and then decide least R. Least R. Remember, this is the usual. Always decide area of cross-section, then radius of gyration about ZZ axis, about YY axis. See, what you call ZZ is, in IS handbook is XX, but we call ZZ. And then YY, least R, based on the least R, proceed further. Okay, start. Now, take the first question. I will read the question, dictate it. Question number 1 has got two parts. Question number 1, A roll steel joist ISHB 350 at 72.4 kilogram per meter is used as a column of effective length 5 meter. A column ISHB 350 at 72.4 kilogram per meter is used, an RSJ is used as a column directly, effective length 5 meter. Now, find maximum axial load column can support factored value, or simple language, find design compressive strength of the column. Over. Start. First, tell me, refer to IS 800. ISHB 350 at 72.4 kg per meter. What is the area? Tell me. ISHB 350 at 72.4. No, not 67.4. It is 72.4. There are two 350s. See, you are not seeing. There are two 350s. ISHB 350, one of them is 67.4, other is 72.4. You refer 72.4 for some reason. You refer 72.4. Tell me, what is the area? Area. First area. ISHB 350 at 72.4 kilogram per meter. Area. 9221. I told you no decimal. These all I told you. It is in centimeter square. These all you should learn. We want millimeter. So what? 9221. This I told you for my regular batch earlier. Newcomers should learn it. It is given in centimeter square. You write in millimeter square. Over. Tell me, see, section is here. What is R about ZZ? Answer, tell me. What is RZZ? RZ. First, RZ. ISHB 350 at 72.4 kilogram per meter. RZ. Is it Yellidar? ISHB 350. Yellidar 350. You should give the answer first. If you don't give it, waste. Is it 16.6 centimeter? See, you are not giving answer. ISHB 350 at 72.4 kilogram per meter. RZZ. It is 146.5 millimeter. Okay. 146.5 millimeter. And tell what is RYY. RYY. 146.5 ಅಲ್ಲ ಇಲ್ಲಿ ಕಾಣ್ತಾನೆ ಇಲ್ಲ ಸರಿಯಾಗಿ 52.2 RYY is 52.2 millimeter. Okay. Now little later, remember, you need one more property. I don't know what happened. There's some problem with the specs. It's not properly sitting there. I think I need square some. Seeing double, because it's not little loose, I think. Okay. Little later, there is one more problem is there. You require buckling class. Remember, make a note. To decide the buckling class, you require one term called, see, there only. I'll tell you now only, where is the buckling class? A property is there. Page number. Page 10. For RSJ, you require breadth of flange and thickness of flange. Therefore, right now, write one more data. For a same section, tell what is breadth of flange and thickness of flange. Remember, if any value is not there in IS code, you have to refer IS handbook. IS code, they are given page number, lastly they are given. But some of the data are missing there, like moment of inertia is missing. So if you want any extra data, you have to refer IS handbook. Tell the answer. What is breadth of flange? Breadth of flange is, I know it, it is 250 millimeter, guaranteed. Correct? 250. Tell me thickness of flange. thickness of flange. Don't give wrong value, I am depending on you. Don't give wrong value. Thickness of flange. At any cost, don't give wrong value. 11.6 millimeter. Okay, done. So, breadth of flange over thickness. What is depth of section H? Tell me. See there. What is depth of section H? This depth of section H. Depth of section H. No, don't refer code. I told you. When it is ISHB 350, that is depth of section H, that is flange to flange outer, is always this number. I told you, don't refer it. Don't write also, not required. Sometimes people will laugh. I will ask seriously, how much? Some will start such IS code. Then somebody will tell him, hey, 350 man, like that. Okay. Now, KL is 5 meter over or equal to 5000 millimeter. Okay, now, tell me, what is the least R? Tell me, what is the least R? 146.5, 52.2. Least R is 52.2 millimeter. Remember, that is your what? That is RYY. That means this column, if at all buckling takes place, buckling will be about XX or YY. Tell me, when KL by RYY is least here, so if at all a column buckles, the buckling will be about which axis? Buckling will always take place where weakness is there. So if at all column buckles, it will buckle about which axis? Tell me. It will buckle about which axis? If at all column buckles, finally the buckling will be about which axis? No answer, you are not giving answer. I told buckling will be always about the weaker axis, YY. So remember, therefore, in this question, YY is critical. So, therefore, calculate KL by R. Remember, KL by R about YY. How much? 5000 divided by R. 52.2. What is the answer? 5000 by 52.2. What is the answer? One nimisha. I am changing the question. Instead of 5 meter, I am making it 4 meter for some reason. Change the question. You make it 4 meter. Some reason is there. I will tell you later. Instead of 5 meter, make it 4 meter. Tell the answer. 4000 by 52.2. How much? KL by R. 4000 by 52.2. Effective length is changed. 4 meter. In the question, change the data. Take effective length equal to 4 meter. KL by RYY. How much? 76.95, 76.63. 76.63. Okay. 76.63 is dimension. There is no unit for this one. It is a ratio. 76.63. Okay. Now you require FCD. So you should know which table number. Therefore, now decide buckling class. Buckling class. Ready. Table number 10. Table 10. Remember what? Buckling about which axis? Tell me. Buckling about which axis? Buckling about YY. So therefore, if table 10, if you refer for RSJ, table 10, you refer for RSJ, rolled steel joist. Sorry, rolled I section. Starting, you require a term called H divided by TF. How much? H is 350 divided by thickness of flange is 11.6. Answer. You require a term called H by TF. How much? 350 divided by what? 11.6. Answer. 350 divided by 11.6. H by BF. Sorry. H by BF. BF is 250. Oh, thickness later. H by BF. H by BF. Answer. No, not TF. H by BF. Actually, this will decide the shape of the cross section. Some people call aspect ratio. Okay. It is also called aspect ratio. 1.4. Okay. 1.4. Now, see there. upper side is for more than 1.2, lower side is for less than 1.2. So this is more than 1.2, correct? More than 1.2. Therefore, tell me, upper side values are for more than 1.2, downside, little down they are given for less than 1.2. So you have to refer upper or lower. Upper side they told the reason, they explained when it is more than 1.2. Lower side they are given when it is less than 1.2. Which one you have to refer? Refer upper. Now if you see upper side, you need one more thing. Thickness of flange. How much answer? 11.6 millimeter. Compare with 40 mm. It is less than 40 mm. So if you see there, if you see upper side, H by BF is more than 1.2, thickness of flange less than 40 mm, then from table 10 for buckling about YY axis, tell me buckling class, bega. What is the buckling class? Fast. Buckling class is what? For upper side, for buckling about YY axis, buckling class is B. Okay. Buckling class is B. Therefore, to get FCD, refer table number, which one? 9B. If buckling class is A, refer table 9A. If buckling class is B, refer table 9B. For buckling class C, refer table 9C. If buckling class is D, refer table 9D. Our buckling class is B, table 9B. Okay. Take Fy equal, taking Fy standard. We will take Fy equal to 250 MPa. Then from table number 9B, you can see there KL by R and FCD. FCD is in what? In MPa. Okay. KL by R. Our KL by R is how much? Our KL by R is, tell me the KL by R, 76.63. 76 is not there, 70 is there, and 80 is there. Tell me, for 70, what is FCD? Bega. For Fy 250, for KL by R equal to 70, FCD. Don't give wrong value. Do not give wrong value. 166. I am believing you. If tomorrow, I do not want any comment tomorrow in YouTube. Wrong values from the table. For other one, 150. At least one more percentile, correct or not? Table 9B, Fy 250, for KL by R equal to 70, 166, for 80, 150, correct? One more person confirmation. Someone should tell yes, correct. Because I do not want comment tomorrow. Someone will tell, after all I can tell. See, I have not seen the IS code. Somebody who is attending the class, he has given. Okay. Therefore, if I will tell him, if it is wrong, write the correct value. Don't tell me all these things. If I see the table and write, you tell me. I am taking class. Someone told from table, I wrote it. Important is procedure. Now, therefore, for KL by R equal to, what is the answer? 76.63. We get FCD equal to, in MPa, by linear interpolation. Those who find difficulty for linear interpolation, I made crystal clear, very, very easy method, no writing required. You can do such a high speed, somebody should be shocked by your speed. Refer to my channel playlist where I made 3 classes. What it is called mathematical concept. I think interpolation is mathematical concept, class number 3. Refer that one. Answer 155.39. It is 155.39 MPa is the error stress. Therefore, design strength of the column PD equal to FCD into A equal to FCD is 155.39. Area of section is 9221. 9221. This will come in Newton, or tell the answer in kilonewton. See, it will come in Newton. You will get something into 10 to the power 3, divide by 1000, tell in kilonewton. You will multiply, you get the, this is Newton per mm square, that is mm square, Newton per mm square into mm square will give you Newton, you get the answer in Newton, divide by 1000 and give kilonewton. 1432.85. 1432.85 kilonewton. Now, lastly, over. See, this is what? This is factored axial compressive force, column can resist, column cross section can resist, okay. Now, by chance, make a note. Suppose you are asked to find what is the safe load. What is the safe load? What is the safe load? Remember, safe load means always working load. Factored load is ultimate load. Suppose somebody wants, okay, you don't talk about that factor at all. Tell me practically how much load I can apply. Then you write, therefore, safe load, if you want, working load condition is 1432.85 divided by 1.5. What is the answer? Nobody should ask, sir, what is that 1.5? There is a limit for asking. Answer, safe load divided by 1.5 is the safe working load. That much practically you can apply if the load is purely axial. 955.23. 955.23 kilonewton. Tell me, is the question fully clear? I will tell the reason for you. I want to discuss something. Actually, that discussion, furthermore, I will tell in your class, not here. When I continue next week in the Zoom class, when I go to design part, I will talk about more concepts, but little bit I will tell here, little bit. Everything clear? Little bit I will tell here, clear. Okay, now this question is completely over. Therefore, remember one note required little later. Suppose the column is ISHB 350, it is this way. Tell me, this width is 250. This is 350. Yes or no? Tell me. Just a note. This is 350 millimeter. Column is like this. This column, it's axial load, factored axial load. Okay. Where I shall write? Okay. Somewhere there. This is 250. No, this is 250. Some reason is there for writing. Practical concept. This width is 350. Then this column, factored axial load, it can support is 14. It is PD. Design strength is 1432.85 kilonewton. Means service load, safe load is 955.23 if you want, and corresponding safe load is 955.23 kilonewton. Clear now? You require little later. When its effective length is what? When it is effective length, L effective is, or KL, okay, I will put KL. When its effective length KL is 5 meter. Okay. Now, go to question number 1B. Once again consider a RSJ. This time consider not ISHB 350, consider ISMB 450. ISMB 450. Tell the weight per meter. ISMB. Last time HB, now MB. Tell me, weight per meter. Today's class concepts are covering. Weight per meter, ISMB 450. Only one column is there. Weight per meter. Bega. ISMB 450, it's weight per meter. Weight per unit length. Ishtottu beka. ISMB 450. That means I have to search. You are not 72.4. Again at 72.4 kilogram per meter. Right here. Oh! Kannadadalli Udgara. Hindi I don't know. Exclamation. Oh! This column and that column both are having same weight. Yes or no? Both are having same weight. Tell me yes or no? Both are having same weight per meter. Yes or yes? Therefore, if you buy from the shop, what about cost? Cost of steel is always weight based. What about cost? What about cost? Same weight. How much you pay for ISHB 350? Of course, here dimensions are changing. Area is same. How much you paid for ISHB 350? How much you have to pay for ISMB 450? Tell me. Same column. If you change your mind and you are going to provide ISMB 450, same amount. Okay. Then why you do the question? I will tell you. Now see, last time this was 250. This is how much? This is 250. This is 350. But this time, see there, this I section is somewhat changing. It is like this. It is like this. This I section is like this. Today I will discuss all this concept briefly. Little bigger, thicker. Oh, some change. Now, this is your breadth of flange. This is your depth of section H. This is thickness of flange. This is TW. Once again, this is ZZ axis. Red I am not using because, okay, black will do. This is YY axis. Now, your breadth of flange is not 250. Tell breadth of flange. Breadth of flange. How much now? Now, breadth of flange is not 250. Breadth of flange is changing. This is a concept question. I will give an example for you in the end of the class. Why it happened? Breadth of flange. Properties are changing. It is 150. Yaar heliddu? ISHB, 150, correct. 150 millimeter. Thickness of flange is, I think, 17.2 or 17. What is thickness of flange? 17 or 17.2 irbeku. 17.2 or 17. Thickness of flange. You are not giving answer. Thickness of flange. You should give the values little fast. Should not waste this much time. Type immediately. Thickness of flange. Otherwise, see, I had to put the pen somewhere here, go there, lift the IS code, search the page. You got ready-made with you. Still you are not telling. See, this is what is unnecessary. Class is delayed. This because of not giving quick answer, time is wasted unnecessarily. Yeah, you are not telling. Okay, what to do? If you do, if this much no cooperation means what I can do? Now I have to search here ISMB 450. ISMB 450. Thickness of flange is still you are not told. Okay. 17.4 millimeter. And its area equal to 9227. Same as last time. But someone will tell, sir, last time it is 9221. Ayo, that is because of approximation. Because of their curvature, all slight changes. Okay, 9227, last time 9221, both are same. 9227. Its RXX is 181.5. Its RXX is 181.5. And its RYY is ISMB 450. If you do this way, difficult to take the class. Remember, it is difficult to take the class. 181.5. You are making me struggle. In the summer here, you are actually putting trouble to me by not giving answer. 30.1. Now if you tell, I am not listening, sorry. Now I am not listening. I am not asking you anything. You are not given the answer when I require. So I am not expecting anything from you. Sorry, leave it. 30.1 millimeter. Therefore, the least, remember now, last time cross section for this one, your RXX was, your last time number, your RXX was ISHB 350 at 72.4 kilogram per meter. RXX was 146.5. Last time it was 146.5 and your RYY, not XX, sorry, RZZ. Ayo, this is a habit. What to do? This is a habit. RZZ was 52.2 last time. Okay. Now leave it. Now, therefore, least R is 30.1 millimeter. Once again, YY. So, your KL by R will become 4000 by 30.1. I do not have calculator. This time you have to give the answer. I can't do anything. I told I am not expecting anything from you, but I don't have calculator. Answer, KL by R. 132.89. 132.89. Okay. Then, buckling class, table 10. Buckling about YY. H by BF. This time your H is 450 and breadth of flange is 100 and breadth of flange is 150. Tell the answer. 450 by 150. What is the answer? 450 by 150. Answer. 450 by 150. It is 3. If it is 3, again more than how much? Table 10. See, you are not cooperating. Because of these things only, time is wasted. Again it is more than 1.2. And thickness of flange is 17.4. Less than 40. So, table 10, buckling class, once again B. Correct? Tell me buckling class. Which is buckling class? Once again, buckling class is B. Therefore, table 9B. Table 9B, your KL by R is last time it became between 70 and 80. Right here, last time your KL by R came, how much? Your KL by R came last time 76.63. Okay, last time. This time, your KL by R, how much? 4000 by 30.1. 4000 by 30.1. How much? Again, no answer. Oh, you wrote it already. 132 point, okay, already told. 132.89. Okay, 89. Now, so now you require for 130 how much? 140 how much? Tell me for 130. And accordingly, last time your FCD came how much? 155.39. Nodi. Last time answer. Okay. These all for the first question. Your A question. These are all for A. When section is ISHB. ISHB 350. Now answer. For 130 how much? You are not giving answer. For 130 how much? Oh, you no answer, nothing. You are not telling anything. How much for 130? How again I have to go there, refer the table and tell. Time waste. 130 is 91.7. For 140? For 140. I don't know why it's happening. If there is no contribution from you, it is very difficult to take the class. 130 is 91.7. 140. You are taking hours together to type one number. Somebody, if you do this way, what I can do? Leave it. Leave it. Not expecting from you. Because why? You are already wasting time. Putting me in lot of trouble. Not giving answer properly. Half-heartedly attending table 9B. for 130 FY 250. 91.7. Correct. Adu correct. 130 is 81. Allu tavkas. 130 is 81. And for 140 it is. How much time required? 71.8. Okay. FCD value. Now tell me. Now I don't have calculator. Therefore, for KL by R equal to, KL by R equal to 132.89. Tell me FCD value. For KL by R equal to 132.89. Tell me FCD value. FCD value. 78.34. Okay. I don't know. I will believe you. 78.34 for 132. Okay. Now, therefore, FCD into area will become 78.34 into area is 9227. 9227. It comes in Newton. Tell the value in kilonewton. Tell the value. Tell the value in kilonewton. 78.34 into 9227. 722.84 kilonewton. Okay. Now, this is the factored axial force column cross section can resist. If cross section is ISMB 450. Okay. What shape load if they want? Answer is what? 722.84 divided by 1.5. Tell the answer. Shape load. 722.84 by 1.5. 722.84 by 1.5. I will give an example for you. 481.9. 481.9 kilonewton. So this is the answer for second one. Now, little discussion is there. I will go for little brief discussion. Sensitive and more information I will tell you in your usual class. Because why? Reason also is there. If more publics are there in the comment, in the viewing, I would have told here. People are always seeing record one only. So therefore, they don't deserve it. Okay. This is last time ISHB 350. Weight per meter is what? 72.4 kilogram per meter. Now, note our B column is something like this. Something like this. Now see, this is rough sketch actually, not neat sketch actually. This is 150 and this is 450. Oh, this is 450. But what happened is, this is 250 by 350, 150 by 450. But area is same, weight is same, cost is same. This is your ISMB 450. Now column is like this. Effective length is same, KL equal to 5 meter. Now the load it can support is how much? 722.84 kilonewton is design strength PD. Or if you want safe load, it is 481.9 kilonewton. And here your RZZ is high value. Nodi. High RZZ 181.5 and your RYY is 30.1. Here see, RZZ is 146, RYY is 52. So 52 is critical here. Therefore 30 critical. Here FCD came lesser. How much? Lesser. FCD came. What is FCD value? Anybody can tell? I rubbed it out. What is the FCD you got? FCD you got 78.34 FCD. FCD is 78.34. 34. Okay. Now, make a note. Those who want to make a note. This is the second column. I will remove everything. Both are of same material and same cost, same weight and same area. Only thing is arrangement is different. Clear? Sectional area also is same. Money wise, cost wise also same. Only thing is arrangement. Like there is one site 40 by 40, or say one site say 40 by 60. There is another site of 20 by 80. Tell me, which is better site? One site is 40 by 60. You want a good bungalow, a beautiful bungalow. Nodi. 40 by 60 site is 2,400. 20 by 80 site is also, other is 40 by 60, 20 by 120, 20 by 120. There is one site of 40 feet by 60 feet. Another site of 20 feet by 120 feet. Residential area. Residential area. Tell me, among these two, where you can build a beautiful bungalow? Tell me, where you can build a beautiful 40, 60. This looks very, very odd. 20 by 120. What is this? Thin and deep. Yes or no? They will tell site is not good. It is okay for apartment or some ordinary lengthwise buildings. But single building, a beautiful house you can build in 40 by 60. This is good. Clear? Clear or not? This is the best one. Now, therefore here, see, both the columns are of same material, same length, same cross-sectional area, same weight. Money also, पैसा भी same. एक ही दोनों का कीमत एक ही कीमत. You pay 20,000 rupees for that one. This also 20,000. But because of the sectional arrangement, this column capacity is 1,432. This column capacity is 722. Almost half. Yes or no? Almost half of that one. Tell me yes or no? This column is so strong, 1,400. This is weak, 722. Strength is of half. Tell me why reason? Because in this class, briefly I will tell. Strength depends upon least R. Here least R is 52. This R is useless, yes or no? The higher R is useless. Tell yes or no? Higher R is useless. Higher R is useless. Weaker R is required. So, here weaker one is 52. Here, higher R further increased, 181. Again, 181 is useless. The weaker one came 30.1. Therefore, tell what? Here, the lesser R is more. Therefore, that is stronger. This is weaker. Or, I will give an example for you. See, a section of same area, one side somewhat square, nearly square. See, a rectangular section, 30 by 40, 300 mm by 400 mm column. Another is 200 by how much? 200 by 600. Tell me, which is weaker? One column is this way, see, 300 by 400. Other column is this way, 200 by 600. Which is stronger? Which is better? First or second one? One column is 300 by 400. 30, 40. Site like, not site. 30 by 40. 300 by 400. Other is 200 by 600. Lean and thin. First is better. Why? Buckling, first one, weakness is 300. Second one, weakness is 200. Clear now? That's why in case of column, do you want bulged section or thin section? Nodi, here somewhat bulged, here thin, slender, here bulged, somewhat this way, here somewhat this way. Which one you want? Bulged or narrow? Do you want bulged or narrow? for compression. Bulged or narrow? Do you want a bulged section? You want a bulged section. Okay. Or I'll give a practical example. Practical example. Imagine two people are going in the road. There is a condition. See, whether buckling is about XX or YY, column has got only one axial load capacity. Correct? Okay, now, two people are there. This section, A and B are the two people. In two-wheelers, A can drive up to a speed of 100 kilometers per hour. B can drive up to only 40 kilometers per hour. But remember, rule is there. Both should go together. Column load is same for both. You cannot apply different load. Both the people have to drive together. Tell me. So, now, tell me here. Your journey time will depend on 100 speed or 40 speed. Condition. This person will tell, I can drive at 100. This person can tell, I can drive only at 40. Above 40, I never go. I get afraid. I get panic. He will tell, above 40, I get panic. Tell me. Now, your driving time duration will depend on 40. 100 is no use. Correct? 100 is no use. Okay, now, that is this, which section? Tell me. Which section? That is which section? Weaker section, 40. That is your B case, thin. Okay, now, you go one more case, another case, where A has got not 100 capacity. A has got lesser. He can drive at 80 kmph. B person can drive at 60 kmph. Now tell me, your speed you can go. One is A can go at 100, but B can go only at 40. So 100 is useless. Your time, your duration depends upon B, 40. Now, answer, 60. So, compared to last time, better or bad? Tell me. Compared to last time, good or bad? Compared to last time, good or bad? Better. Or, see, this 80 and 60 is this case. That is somewhat, both are nearby. The other one is too high, other is lesser. Then too high is of useless. So what they made is, this ISMB 450 section is like this. This is your ISMB 450. Tell me, stronger or weaker? Tell me, stronger or weaker? Width is 150, depth is 450. This is good or bad? Good or bad? ISMB 450. For a column, good or bad? Bad. This is bad. Now what they done is, they changed it like this. Same area they maintain. The weakness, this weaker one, they increased, stronger one, they decreased. So that this area and this area, both are same. Suddenly strength, instead of what? Instead of, strength is to 100 and, instead of, instead of 722, strength jump to 1400, double, only by magic. Therefore, remember, for columns, the most ideal RSJ is which one? IS. For columns, the most ideal RSJ is IS. HB or MB? HB or MB? Most ideal RSJ for column is HB or MB? HB. H section, it is HB. See, H is like this. I section is like this. I know it. Now clear? But remember, make a note. Now, ISHB is enjoying. It is telling, I am so strong. Hey, ISMB, you are very weak. I have got it. I have got the same area as you. Everything is same. But both are having same vehicle. But when it comes to capacity, I can take 1432. You can take only 722. You are very, very weak. So ISHB is the boss. He will laugh at ISMB. But remember, ISMB will take revenge. When? Tell me. ISMB will take revenge when your RYY is useless. Your RYY becomes useless. Only XX considered, sorry, XSL, ZZ. Only ZZ considered in case of beams. Therefore, when you go to beams, story will change. Which is ideal for column becomes weaker for beam. Tell me now. I will discuss in the beam case. So, if you go for a beam case, tell the answer. Which is stronger? MB is better. Or, right now I will do one thing. Because later there is no time. I will tell you now one small important concept today. Now, this is for concept. Therefore, only for concept. One of them is ISHB 350, other is ISMB 450. At 72.4 kilogram per meter. This also at 72.4 kilogram per meter. If used as a column, tell me king, who is the king? Who is the king? If used as a column, who is the king? HB or MB? No, HB. If you use it as a column, HB is the king. He will tell, I am the king. King, HB. Strength came 1432.85 kilonewton. This is very, very weak. Weak. Strength came only what? ಎಷ್ಟದು ಈಗ ಅಳಿಸ್ಬಿಟ್ಟಾನು ಅಯ್ಯೋ ಎಷ್ಟು ಬಂತು ಈಗ ಆನ್ಸರ್ ಅದು ವಾಟ್ ಇಸ್ ಆನ್ಸರ್ ಯು ಗಾಟ್ 700 and forgot ಫ್ಯಾಕ್ಟರ್ಡ್ ಲೋಡ್ ಎಲ್ಲೋ ಇದೆ ಅಲ್ಲಿ ಬಿಡಿ half the value 722.84 722.84 therefore king ISMB IS what ISHB wins that is this section is like this nodi this somewhat square type this section is like this ಅದೇ ಏರಿಯಾ ಥಿಕ್ನೆಸ್ ಜಾಸ್ತಿ ಇದೆ ಎಕ್ಸಾಕ್ಟ್ ಸ್ಕೇಲ್ ಬೇಡ ಬಿಡಿ ಓ ಇದು ಬೇಡ ಬೋತ್ ಆರ್ ಸೇಮ್ ಏರಿಯಾ ದಿಸ್ ಈಸ್ ದ ವಿನ್ನರ್ ದಿಸ್ ಈಸ್ ದ ಲೂಸರ್ weak this is strong this is weak okay now do one thing you have to believe me agreed you have to believe me now agreed what I am doing now you have to believe me because that will come in the beam case I will do it today only why once again I can't go to beam and ask you property clear I will go for the beam case briefly you have to believe whatever I tell you will believe me will you believe me whatever I tell yes agreed nodi when you use when same two sections same two RSJs are used as beam nodiga then your one who got royally beaten one who got insulted see this got insulted ISHB will tell hey you are useless I am so strong you are useless one who got insulted will take the revenge see now when you use as a beam then only ZZ axis counts you imagine laterally supported these all will cover later laterally supported and low shear and also assume web not susceptible susceptible to shear buckling. These all I will explain later. You just believe me. Then you require Z elastic and Z plastic. You require Z elastic and Z plastic. Okay, start. If you consider ISMB 450 as a beam, as a beam, not column. ISMB 450 got royally beaten by column. It is thrown outside. It got insulted. Now see, this is your ZZ axis. Tell me what is Z elastic and Z plastic. Tell the answer. What is Z elastic, Z plastic? Tell the answer. Refer the handbook. You tell me. What all I am telling you, believe me. Because these all will come in the beams. Today I want to finish this case. You should study this one after I complete the beams. Remember, not now. You stop here. Those who are interested in column, you stop there. If you want, leave the class now. Leave the class. This is for my regular students, regular batch. If it is a beam, ISMB 450. What is Z elastic? Bega. Again, you are not telling. What is Z elastic? And imagine beam is simply supported. Z elastic. Nodi table. Z elastic. Oh, you are so no cooperative. I don't know what happened today. No cooperation, nothing. I think better close the class. If this way you give the answer, I better close the class then. No point in continuing. This much time you are taking to give properties. Your property page is there where you are given area, etc. You can see now you are giving after half an hour. ಏನು 1553 ಅಬ್ಬಬ್ಬ ಏನು ಅಂಥ ಪೆದ್ದ ನಾನು, ಅಂಥ ಪೆದ್ದ ಅಲ್ಲ ನಾನು. ಐ ಆಮ್ ನಾಟ್ ದಟ್ ಮಚ್ ವೀಕ್. ISMB 450ಗೆ Z elastic is ನೋಡಿ, you are not giving the answer. ISMB 450 I am telling, which is right. Z elastic is 1350.7. ಇಷ್ಟೊಂದು ಕಷ್ಟನಾ? 1350.7 10⁻³ millimeter cube. And Z plastic is ಏನೇನು ಹೇಳ್ತಾ ಇದ್ದೀರಾ ನೀವು? ISMB 450. Z elastic is 1350. 1533.36. 1533.36 10⁻³ millimeter cube. Again, you are wasting my time. A lot of time is wasted. This type of waste is you cannot justify it. Okay. Now you will know, and I am so sure that for this section your beta B will come 1. Why means believe me. Believe me. Today you believe me. Today you believe me, later you worry. Now because the beams. Then design bending strength is that is MD equal to beta B ZP Fy by gamma MO, but not more than 1.2 ZeFy by gamma MO. Answer equal to 1 into ZP 1533.36 10⁻³ into 250 divided by 1.1 and not more than 1.2 into Z elastic 1350.7 10⁻³ into 250 divided by 1.1. Tell me this answer. This will both will come in Newton millimeter. It will come in Newton millimeter. Tell me in kilonewton meter. Tell me in kilonewton meter. Attar madi. Tell the first answer in kilonewton meter. Tell me in kilonewton meter. First answer. ಏನೇನೋ ಹೇಳ್ತಾ ಇದೆ 1871 ಎಲ್ಲಿದೆ ಯಾವ ವ್ಯಾಲ್ಯೂ 353.04 ಫಸ್ಟ್ ಒನ್ 353.04 ಸೆಕೆಂಡ್ ವ್ಯಾಲ್ಯೂ 353.04 first value, second value. These all I will explain in the beams. Someone will ask, what is going on? He has not explained. No, this is a beam part. I am telling now because to save the time later. Second one, if any calculation mistake is there, you are responsible. 368.37. 368.37. Therefore, for this beam, design bending strength means MD, or means what? How much factored BM cross section can resist is whichever is least is 353.04 kilonewton meter. That is for your ISMB 450. This is for that which what was insulted, when used as what? Tell me. When used as what? This is for that section which got insulted when it is used as same section, when it is used as column, at the column, nodi, used as column. Okay. Now do one thing. Consider the second one. Which one last time? Now consider that ISHB 350 at 72.4 kilogram per meter, which was king when used as a column, which insulted this beam. Now see what happens. For that one, tell me Z elastic and Z plastic. You will not tell. I should search. You will not tell. I know. ISMHB 350 at 72.4 kilogram per meter. Z elastic is 1131.6. 1131.6. Correct? ಇವತ್ತು ಲೈಕ್ ಕ್ಲಾಸ್ ಯಾಕೋ ಓವರ್ಲ್ಯಾಪ್ ಆಗ್ತಾ ಇದೆ. ISMHB 350. ISHB 350. Yes. It is 1131.6. 1268.69. 1268.69. 10 to the power 3 millimeter cube. 10 to the power 3 millimeter cube. Correct answer? Tell me. Correct? Correct or not? Correct? 1094.8. ಎಲ್ಲಿಂದ ಹೇಳ್ತಾ ಇದ್ರಿ ನೀವು? 1094.8. ಸಿ IS code. In the IS code, section ಮಾಡಿದ Z elastic. ನೀವು ಸರಿಯಾಗಿ ಹೇಳೋದೇ ಇಲ್ಲ. ISHB 350. ಕರೆಕ್ಟ್ ಆಗಿದೆಯಲ್ಲ? ISHB 350 is 1094. ಇಲ್ಲ. It is 1094 ನೋಡಿ. 1094 ಪಾಯಿಂಟ್ ಸರಿಯಾಗಿ ಕಾಣ್ತಾನೆ ಇಲ್ಲ ಇಲ್ಲಿ ನೋಡಿ ನೀವು. ದಿಸ್ ಈಸ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಇಫ್ ಯು ಡೋಂಟ್ ಗಿವ್ ದ ಆನ್ಸರ್. ಇಫ್ ಯು ಡು ನಾಟ್ ಗಿವ್ ಪ್ರಾಪರ್ ಆನ್ಸರ್, ದಿಸ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್. ಎಲ್ಲ ನೋಡಿ ಅಗೇನ್ ಜಂಪಿಂಗ್ ಸಮ್ವೇರ್. ISHB 350 72.4 kilogram per meter. ಅಲ್ಲಲ್ಲ, ಎಲ್ಲಿದೆ ISHB 350? I wrote correctly at 72.4 kilogram per meter. It is 1131.6. ಕರೆಕ್ಟಾಗಿ ನಾನು ಕೊಟ್ಟಿರೋದು. ಅಯ್ಯೋ, ISHB 350 at 72.4 kilogram per meter is 1131.6 and 1268.6. ನಾನು ಕರೆಕ್ಟಾಗಿ ಬರ್ದೀನಿ, ನೀವು ಪುನಃ ಮಿಸ್ಗೈಡಿಂಗ್ ಮೀ. ಯು ಆರ್ ಅಗೈನ್ ಮಿಸ್ಗೈಡಿಂಗ್ ಮೀ. ನೋಡಿ, ಅಗೈನ್ ಯು ಆರ್ ಮಿಸ್ಗೈಡಿಂಗ್ ಮೀ. You are not giving answer, and when you give the answer, you tell wrong answer. Okay. Ega. Now, for this section, it is 68. Adu martu hoytu 68. ಅದು ಮರ್ತೋಳಿ, ರಬ್ ಆಯಿತು. 6.8 ಅದು 6.9. Now for this one your beta b will be, sorry, I have to check it. I can't tell. It is not one, I think. Check ಮಾಡ್ತೀರಿ ನೀವು, ವರಿ ಮಾಡಬೇಡಿ. What is beta b you will be knowing when you go later, not right now. ನಿಮ್ಮ ಕೇಳಿ ಹೇಳೋದಿಲ್ಲ. ಏನು ಬೇಕು ನಮಗೆ? b/tf, b/tf 75 125 by thickness of flange. thickness of flange ಎಷ್ಟು? ISMB 350ಗೆ, ISHB 350ಗೆ ಕಾಣ್ತಾ ಇಲ್ಲ ಸರಿಯಾಗಿ, ಎಲ್ಲ ಒಂದು ಎಲ್ಲ ಮಿಸ್ಸಿಂಗ್. ISHB 350ಗೆ thickness of flange 11.6. Tell me what is the answer? 125 by 11.6. Tell me that answer. I don't have calculator. What is 125 by 11.6? 125 by 11.6. What is the answer? Tell the answer. I don't have calculator. 125 by 11.6. 10.78. 10.78. ఇప్పుడు 10.78 ನೋಡ್ತೀನಿ ಇಲ್ಲಿ. .78 means section is not even compact. Section becomes semi-compact. It becomes semi-compact. Your beta b equal to semi-compact. Tell 1131.6 by 1268.39. Tell the answer. 1131.6 by 1268.69. Tell that answer. 1131.6 by 1268.69. Answer. ಬೇಗ ನೋಡಿ. 1131.6 by 1268.69. Answer. 0.892. So beta b is 0.892. Y means these all will be covering in case of beams. Clear? Today you believe me. Clear? You believe me today. All will come in the beams. Clear or not? These all will come in the beam case systematically. Today you believe me because I want to compare. Beam is still not started. But luckily I know about the beam. Since I know about the beam, I can tell the concept, not values. Agreeing? You should believe me now. Don't ask any question. Okay. Now, its design bending strength MD equal to, same formula what I wrote, beta b is 0.892 into ZP is 1268.69 10 to the power 3 into 250 by 1.1. Tell the answer. Equal to, in kilonewton meter. Answer. 0.892 into 1268.69 10 to the power 3 into 250 by 1.1. It will come in Newton millimeter. Tell me in kilonewton meter. Bega. Tell me in kilonewton meter. 257.2. 257.2 and also not more than what? 1.2 into Z elastic. 1268.69 10 to the power 3 into 250 divided by 1.1. Again Newton millimeter. Tell me this also in kN meter. Therefore MD equal to, MD for ISHB 450, which was the boss king in case of column, but for beam. Answer. It was 308.62. 308.62. So answer is 257.2 kilonewton meter. So now make a note. When used as a column, Same, both are same section. Your ISHB is having a strength of 1432.85 kilonewton, and your this is the very strong. Your ISMB has got a strength of 700 and ayyo. What is that answer? 700 and 722.85. 722.85. That is very, very weak. This is when used as a column. So column ISHB is the king one. This one. But when you use as a beam, then same ISHB 350, its design bending strength is only 257.2 kilonewton meter, whereas ISHB 350, this is whereas the design bending strength is what? Its design bending strength MD is 257.2 kilonewton meter when you say beam. But the one which lost the battle last time, its design strength is MD equal to 353.04 kilonewton meter. Tell me, therefore, when the beam comes, tell the stronger as a column, which is stronger, HB or MB? As a column, which is stronger? As a column, which is stronger? Same cost, everything is same. As a column, which is stronger? HB is stronger. But as a beam, principle will be covered later in the beams. Today you believe me. What all I wrote here, you just believe me. That's all. As a beam, MB is the king. Clear? So practically also, for a column, most ideal RSJ is ISHB. For beam, most ideal RSJ is ISMB, not HB, MB. And more about this concept, I will tell you in the Zoom class, not in this YouTube class. More I will tell there. For beam portion, whatever I wrote, you believe me, but you study after I finish the beam. Okay. Fully clear? If fully clear, tomorrow I will take built-up columns, like 2 I sections with plate, 2 channels with plate, etc., etc. All those built-up sections. And other class, I will take one design example for general public. Then I will stop this YouTube class, again go back to Zoom class and start with all finer concept. Okay, thank you. Don't waste time like this. Next time onward, give quick answer. Do not waste this much time. Okay.